All right, in this video, we're going to look at the first four problems of the 5.2 worksheet with verifying trig identities for it. So we start with number one. Our first thing we want to do is determine which side we're going to keep and which side we're going to change. Now, I'm going to keep the right side because it's simple, cosine of x, and I'm going to change the left side. So pretty simple way to start and talk, but then you got to figure out, well, what do I do to the left side? And that's a common theme, is where do you begin? And in this case, I notice I have a cosine of x on the right, yet I have a cosecant on the left, a cotangent on the left, a tangent on the left. They're not like terms. And so when I want to create like terms when verifying trig identities, I'm going to want everything to be in either sines and or cosines. So I'm going to change the cosecant of x into 1 over sine of x. I'm going to change my cotangent of x and do cosine of x over sine of x. And I'm going to change my tangent of x into sine of x over cosine of x. Now I know they don't have in your mind the same terms because there's a sine there and I want cosines, but really they do. And again, it may look more complicated at this point because you have fractions with fractions. In your mind, it's not looking simple, but it's going to as we go on. We're going to be able to merge things together the more terms we have in common. So if I look at this, and it's the same idea as the beginning is, which is the simpler part, because we'll keep it. And I like this 1 over sine of x. It's very basic. There's not much you can do with it, so I'm going to keep it and just work with it later. But the denominator, I'm going to change. And that's what I want to look at is the denominator is weird. You have a fraction plus a fraction. Now that's something you know how to do. In order to add two fractions together, I need a common denominator. Now you're dealing with trig functions with the trig ratios, but you can do it still. So that's a common theme, by the way, you're going to see throughout our identities is that when you're adding two fractions together, you're going to want to find a common denominator to merge them. So let's do that. The first fraction is cosine of x over sine of x. The second fraction was sine of x over cosine of x. And my job is going to be to merge them together by creating a common denominator. And in this case, I notice, well, this has a sine on the bottom. This one has the cosine. They don't have anything in common. So I'm going to put the cosine of x on the bottom here and on the top here. And this one's missing the sine, so I'm going to put it on the bottom and the top. And so now they have a common denominator for us. The 1 over sine of x I did not change. But the denominator now can be merged together. Cosine times cosine is cosine squared of x. Sine times sine, so plus sine squared of x. And we created a common denominator so I can write it as one fraction now. Sine of x times cosine of x. Still haven't touched the right-hand side of cosine of x. So again, you may think, wow, really hasn't helped so far with what we're doing because we still have fractions with fractions and it looks complicated. And you're kind of right. But we can make it so it works a little bit easier for us because I can look at it. Same idea is that 1 over sine of x we haven't touched yet. I'm going to leave it alone. But I noticed something. I have cosine squared of x plus sine squared of x. I have two trig ratios squared that are being added together. There's a very good chance that is a Pythagorean identity. And it is. Cosine squared of x plus sine squared of x is 1 over sine of x cosine of x. And that equals my cosine of x. So if I take a look at this, we're still on the right track, and notice it's slowly merging, slowly merging. There's another theme, is you are dividing by a fraction. So to divide by a fraction, you keep the top and you flip the bottom. and changes it into multiplication. Multiply by the reciprocal equals the right-hand side cosine of x. And in this case, since it's all multiplication going on here, I have the ability to cross out common factors in the top and the bottom, so my sine of x can cancel out. So I get cosine of x left on the left side, which is what we wanted on the right side. So cosine of x equals cosine of x. Q, E, D. It has been demonstrated for this problem that the left-hand side equals the right-hand side. So before we move on to number 2 is I need you to see common themes that might pop up later on is we had a common denominator. When you have two fractions together, we had to create a common denominator to go from there. We had two squared trig ratios being added together, so maybe that's a Pythagorean identity. I divided by a fraction, so I had to flip and multiply. The problem was all multiplication, so I could cross out common factors in the top and bottom. These are actual themes that are going to appear throughout our trig identities, and it's important to keep that in mind. So let's look at number 2, and let's see if we can figure out what to do from here. And right away, and I'm going to keep that right-hand side equals secant of x. That's very basic. But that left side bothers me because, I mean, look at this. You have a tangent, you have a cosine, you have a sine, yet on the right side I have a secant. So they're not the same. But I do know one thing, is I know secant, just secant is 1 over cosine of x. If that's the only way I can think of off the top of my head to get secant very easily is just put 1 over cosine, which is going to help me because that tells me on the right-hand side, even though it says secant, I'm really dealing with a cosine. So my advice is I'm going to change the left side so we have common terms. So I'm going to change tangent into sine of x over cosine of x. And the other fraction already has a cosine and it has a sine. Now what I'm going to do is I'm going to put this 1 plus sine of x in a parentheses because we need to start looking at that as an object, its own factor. Because notice on this step I have a fraction plus a fraction. Well, how do I add two fractions together? I need a common denominator. So notice that theme is repeating. If you have two fractions being added or subtracted, you're going to want to find a common denominator. And this one, I have sine of x over cosine of x. And plus, I have cosine of x over 1 plus sine of x. In a parentheses, equals my secant of x. So I'm going to create my common denominator. They really have nothing in common, by the way. This is a cosine, this is a 1 plus sine, so it doesn't work that way for us. So what we're going to do is we're going to do the same trick as before. I'm going to put a 1 plus sine on the left, 1 plus sine of x, so I got to put it on the bottom and the top. This needs the cosine on the right, so I'm going to put it on the bottom and I'm going to put it on top. So now, again, it looks complicated, and it is. You're going to have to just do a lot of simplifying to get it down. But notice I created common terms. So let's see how that helps. I'm going to keep the bottom in factored form. Cosine of x, 1 plus sine of x. It's going to make it easier to keep your common denominator there. Factor. And I'm going to distribute the top. Sine of x times 1 is sine of x. Sine of x times sine of x is sine squared of x. And then cosine times cosine is cosine squared of x. And they have a common denominator, so I can use that. So again, what do I do is, well, I noticed one thing. We said secant of x was 1 over cosine. And notice I have a cosine on the bottom. That's awesome. I mean, that's what I want. So I can start to see the structure slowly. I mean, I got a lot of junk there. I got to figure out what to do with this. I got to figure out what to do with this. But I start to see I have that 1 over cosine for it. So let's figure out what we do. Well, if I take a look at this, just like before, I see a trig ratio squared. plus a trig ratio squared. And that's going to make me think, is that a Pythagorean identity? And it is. Sine squared of x plus cosine squared of x equals 1. Which again, if I just leave the bottom alone in factor form, I think is extremely useful because look at our denominator now. Our denominator is sine of x plus 1. Our numerator is 1, well, sine of x plus 1. Our denominator is sine of x plus 1. Well, that's awesome. They can cancel out. It's a common factor between it. So I'm left with 1 over cosine of x. So notice that cosine of x denominator stayed there. It's what we wanted. And cosine of x in the denominator equals the secant of x. So it has been demonstrated that the left-hand side equals the right-hand side. Again, what common themes? Of course, things will look a little complicated, but we're going to have to get more confident with our fractions. Common theme, notice, we can kind of go side by side. I had two fractions added together. I had to find a common denominator. I had two fractions added together. I had to find a common denominator. I had two trig ratios squared. Very good chance it was a Pythagorean identity. I had two trig ratios squared. Very good chance it was a Pythagorean identity. The problem was all multiplication. So I could cross out common factors. The problem was all multiplication. So I can cross out common factors. As themes are there for us to kind of keep an eye out for. Certain structures tell our eyes certain things when we're verifying our trig identities. Let's look at number 3. Now you can do this a few ways. I'm going to use one way to kind of help out with what we're going to be doing in number 3 for it. I can also use another way. So I'm going to do this 2 ways to make it very quick and easy. The first one is not going to relate to number 4. But I can realize the right-hand side is the easy side, equals 1. And I can do what I did in the previous problem, and let's change the sine to cosine. So this is going to say cosine squared of x plus, and this will become sine squared of x over cosine squared of x. And then cosine squared just stays cosine squared. And I can put it over 1 if that makes you feel better. And they're being multiplied. Why is this helpful? Is, well, I now have 2 terms. This one, I'm not going to do anything with. I'm going to keep cosine squared of x plus. If I look at this one, I see it's all multiplication. So I can cross out common factors in the top and the bottom. So that cosine squared goes away, and I get sine squared of x equals 1. And I have 2 trig ratios, squared, cosine squared of x plus sine squared of x, which again leads me to think, man, is that a Pythagorean identity? And by the way, it is. 1 equals 1. QEE. It has been demonstrated. That's a very, I'd say, straightforward approach, switching to sines, cosines. In this case, it helps out. There's nothing wrong with that. It was actually very quick to do. I'm not going to use that technique for it. I'm going to do something a little bit different. And the reason why is it's going to relate to number 4. And I want to teach the themes with these videos, is what things start to repeat. And I notice when I do this problem, there's a cosine squared of x here, and there's a cosine squared of x here. And I can apply my Gcf factoring technique. I can factor out a cosine squared of x. And I would be left with 1 plus tangent squared of x. So this cosine squared I'm going to keep. So cosine squared of x. But this 1 plus tangent squared, that's a squared trig ratio and a number 1, which would make me look to see, is that a Pythagorean identity? And it is. It's secant squared of x equals 1. So again, why is this helpful? Is at this point, if you can see that secant and cosine are reciprocals of each other, if you multiply 2 reciprocals together, you're going to get the number 1. And you can say 1 equals 1 QED. We did it same way as before. If you can't see that they are reciprocals of each other and they're going to cancel out by multiplication to 1, you can still do the same technique we did before, is change everything to sines and cosines. So secant squared of x is 1 over cosine squared of x. And notice a theme repeating. It's all multiplication here. So I can cross out common factors on the top and bottom, and I'll get 1 equals 1 there as well. So that was 2 ways to do number 3, and I don't care which one you do, but I did this one to end with because it is very similar to number 4 on how we're going to do it. Is number 4, I'm going to do something very controversial, is I'm going to work on both sides. So I'm going to simplify both sides. And so if I look at the first one, 1 plus tangent squared of x, I see a square trig ratio with the number 1. Is that a Pythagorean identity? And it is. 1 plus tangent squared is secant squared of x. So I look at the next one, 1 minus sine squared of x. So same idea. I see a squared trig ratio with the number 1, and I ask myself, is that a Pythagorean identity? So I look at the formula sheet, and I'd see it's cosine squared of x equals. Now I'm not going to do the right side yet. I'm going to keep simplifying the left side because I can notice something here. I notice it's secant squared times cosine squared, and those are reciprocals of each other. So again, I see this theme of reciprocals being multiplied, give me 1. And if I can't see that, there's no harm in that. I can just change this to 1 over cosine squared of x times cosine squared of x, again, over 1, if that makes you feel better. And I'll notice it's all multiplication. I can cross out common factors in the top and bottom. Gets me the same end result of 1. Well, that's an easy left side. I mean, that tells me something really good is going to happen on the right side for simplifying. Things are going to start canceling out. And notice what I have. I have a cosecant squared of x here and here. That looks very similar to my Gcf technique in the previous problem. So I'm going to factor out a cosecant squared of x. And that's going to give me 1 minus cosine squared of x. Let me just leave this cosecant squared here. And notice what I have. I have a square trig ratio and the number 1. So I'm going to figure out, is that a Pythagorean identity? And it really is. 1 minus cosine squared of x is sine squared of x. Now look what I have here. Cosecant squared and sine squared are reciprocals of each other. So if I'm multiplying reciprocals, I'm going to get the number 1. And I get 1 equals 1. So it has been demonstrated that the left-hand side equals the right-hand side. But if I couldn't get that, could have I done the same thing here? Could I have changed cosecant squared to 1 over sine squared times sine squared over 1 and cross out common factors just kind of like I did over here? Absolutely. But you start to see that if you have squared trig ratios with the number 1 or squared trig ratios being added or subtracted, there's a very good chance you have Pythagorean identities. There's this idea of Gcf that pops up as well sometimes for it. The idea of common denominators goes through as well for it. So these 4 problems, side by side, 1 and 2, there were some similarities. 3 and 4, there were some similarities. The goal is to hopefully see that. So hopefully this helps you with 1 through 4. We can take a look at the next video that goes through 5 through 8.